Okay, I took the motor out of here, and this is it. And we're going to service it. And I figured out what these two wires do. They reverse the phase of the AC line that turns the motor, so they basically they flip over the magnetic field, makes the motor turn one way or the other. You can see there's a lot of dirt and debris in here. This fiber washer is all filthy and it won't spin. So we're going to fix that. Also, this case is not right. You see it's not in the bushing there. So we're going to fix all of this. So that's the next step in our process. I figured I would go ahead and work on this, and then we can finish recapping, and it's easier to get in there, which I'll show you. I'll probably flip it. Well, I can't flip it upside down. I'm trying to get my camera in a better position so that you can see what I'm doing. It's just hard at this angle to get a good video, but I guess I can set the tripod down on and do that. But for right now, you can see good as we do this, I believe. So hopefully you can see what I'm doing down here. And first thing we want to do is take out the motor and clean it. So we'll start there, and then this is just a little adjustment here. And of course cleaning, you see the dust and dirt in there. We want to get all that out of there. So, and this would be good for if you're working on these. You see there's two coils here that wrap around the I-frame, the laminated core, metal core. There's one there and there's one here. There's two coils. And so the way that this works, if one coil is energized in one direction, in phase in one direction, it's going to induce a magnetic field around the armature in one orientation, north to south, and make the motor turn in that direction, being pulled toward that magnetic field. If they're oriented in the opposite direction, then the motor will go the other way. And it's pretty self-explanatory, but that's what happens. So let's go ahead and take the motor out and be gentle with those coils in the process. These should not be spring loaded, they should just be in there. But we'll take them out, take that nut off, we'll take the other nut off. Okay, so that should come apart. Okay, there we go, there's the armature. We'll just keep it in the order it was in, that way all the washers and everything stay in that orientation. And we'll go ahead and get these screws out. I'm surprised they don't just pull out. Apparently they screw all the way through. Usually they just slide through an iron core, but these must be threaded. Yeah, they're threaded in there. Oh, because that holds the coils too. I really don't need to take this side all the way out, but I'm going to do it anyway. Just to clean it better. Okay. Okay, the only threaded part of the way. Alright, let's set that aside a second, and we'll work on these. Okay, here's the felt washer in here, and it goes through this brass bearing. You see there's a stuff there, you see there's a brass bearing. When you're working on motors like this, just make sure everything's back the way it goes, and you see that bearing can turn, which allows it to have some mobility. And so they just go together like that. And what we're going to do first is clean them out a little bit. I'm not going to clean the felt with this process. Actually, I stamped it rag here, of course, with alcohol. Clean out this little tray here. Okay, put the alcohol in there. Or I could still call it liquid gold. With this pandemic, you can't get alcohol anymore. It costs a bloody fortune. Let's get the mold out. Okay, so we just clean that off a little bit. And we do it that way. And the bolts, get the grease off of them. They're not really that bad, but I just wanted to clean them off. Now this, on the other hand, you see all the residue in there. So we're going to get all that off there. It used to be grease at one time, it's totally gone now. Turned into glue, which old grease always does. Okay, that's clean. Let's clean this one. This one's a little bit shallower than that one, so you don't want to mix them up because they may not be exactly the same size. You can tell where the washer goes, see? That helps. Okay, and Now, this is actually a thicker metal than this one. This one's a very thin brass plate, and no, they're not the same size. See, there's a space between there where the bearing goes and the washer goes. Okay, now that we got that side cleaned out, this, all I'm going to do with him is sort of just lightly push on it here and just let the napkin suck up whatever's on it. There's a little bit of grease there, not much. It's pretty well dried out, but the felt is in really good shape, so that's good. It hasn't deteriorated at all. And if it did, we would just make a new one. Just want to get all the old grease off of there. And not drop it on the floor. No, that part is optional. Okay, try it again. Okay, so we got all that grease out of it. And there wasn't much left, but I just want this to be absorbent as it can get it. And we're going to put some new grease on there. And what I use for motors is the synthetic grease, Super Lube. It's really good stuff, really expensive stuff. And we're going to put a little bit here on the metal where the washer sits. And we'll put the washer on. And you notice I'm not putting any on the washer because I really don't need it. It's the bushing that needs it more inside the bushing than outside. But a little bit will help because over time it'll soak through as it's, keep the unit, it'll keep the unit lubricated. So I'm going to put this guy back in. Where he goes. Actually, I'm going to put a little more, don't leave that on there. So I'm going to just put that there. And the brass on these bushings is absorbent, so over time it'll allow some of that grease to soak through. We don't want a lot, just a little bit there because it's not critical there. Where we do want it is on the shaft of the motor. So we're going to clean that off a little bit. And we'll take these washers. Oh, the washers don't come off, okay. But that's not a removable washer. That's interesting, it should be. No, it's not. It's part of the actual thing. And clean all of this off, get all that stuff off the armature because we don't need it on the armature. Okay, and now I'm going to take this off. See if it comes right off, hopefully that will. Yep. And you see how that goes, so you want to put it back on the same way. And we're going to repeat the process on this side. Right. And it's stuck to that shaft for sure. I'll go. Okay, hold on. Let's do it this way. Yeah. And keep them separate, because you never know, they may be separate. I mean, I haven't broken out my caliper and checked all this down to see if it's all the same, but I think it is, but just to be safe, since I didn't do that, I just put it that way. Okay, now that's clean. I'm going to repeat what we did there. I want to clean this. See, this side's not so bad. Just all the dirt off of it. Okay, and then this guy will just have it in here. So just use the other side. This one had a little bit more grease on it. Not much. Okay. I'm sorry if I'm not in the camera there. Put a little bit of alcohol in this guy just to make him a little more porous. Okay. That guy, it's not too bad. Okay. Okay, now we'll put some grease on that side. Again, we use just a little. Okay, but where the grease is more important is on the shaft. So we don't need it all the way up here because we want to screw this on and we don't need grease on that. But we do need grease on the shaft. Okay. And this is good grease. This will last a lot longer than the original grease that's gone years ago. So just put it right in there. Not too much, but that's okay. We'll take some of it and put it in there. Inside the hole a little bit. And same on this one. Okay. We'll put our screws back through here. There, right there, right there, this guy here, and now we want to clean this up a little before we put it in there. And this is brown bakelite, so it's not really, it looks like it's dirty, but it's really not bad, it's just bakelite. And we get all the any debris or dirt out from inside the coil there. Be gentle with the wires. And just to take the dust off. I'm just cleaning the core, just because I got it out. It doesn't really need it. This side is a little dirtier. Okay. We'll clean them up a little more when we take them off. Okay, so now, I'm going to put this guy back in here.
Alright, I'm going to finish recapping this radio. I got all my caps over here that we're going to be using, and on the side you probably can't see them, and I marked them all on the shield then so that I know which way the shield goes to the ground. A lot of people don't do that and end up putting them in backwards, but there is a polarity. Notice all of these have a black stripe, and that tells you which side goes toward the ground. Of course, most of them are grounded, but so that's obvious. But a lot of them are not, like these are not, and this one's not. And, but the black stripe tells you which side is the more negative side of the circuit. And if you put them in backwards, you can get a lot of distortion, a lot of noise, because the foil in there connects to one line, one of the leads, one or the other, and then it wraps around like a roll of tape, and then the very end connects to the other lead. So whatever end is on the outside is the side that this acts like an antenna. So the part on the outside. So when you touch it, or when noise interference hits it, or an AC line is up near it, it's going to hit that front foil and go right to the lead that connects to that foil and right to whatever it connects to. But if the foil is the ground, any noise that comes in is going to go right to that lead and right to ground and be grounded out. And that's why they have bands on them. That's why they mark them. Today in electronics, it's not critical because everything is current driven, where back then everything was voltage driven, so it makes a big difference. So you got to mark them and you got to measure them because they're not all the same. It's not like you can look at the number and say, oh, it's on this side. No, it don't work that way, because these come down an assembly line on a machine when they're being printed, and they just flip in any old way, and the machine just grabs them and prints on them. It doesn't consider anything about the way they're wrapped. So on the negative side, this is ground all the way up to here. The foil and all of that is the negative. And the anode side goes in the center, which is sensitive to noise. So the other thing you want to do, as much as you can't always control it, but try to, is whatever side is not the shield side, you want the length of the wire as short as possible and the longer on the ground side. So any noise that's picked up, think of it as an antenna. Any noise that's picked up is sent to ground and not to the positive side. If we get all this on the positive side and just a little bit on the ground side, all the noise picked up is going to go down this line to the part you don't want, and it's going to be noise. So that's just a few tips. Now sometimes, like I say here, I couldn't deal with it. Sometimes you just got to do what you got to do, but try to always make the longer side the ground. You see there, I got the longer side as the ground and the short side for the positive. This one didn't matter, they're both short. That one, that's the ground side, this is the positive side, but it's in an area where there was no other way to do it without it being in a bad situation. So you can't always do it, but try to keep the lead on the positive side short. Of course, that means you need to know which side is the ground side, or you can't even do that. Okay, a couple other things I did, just that might, as you're working on these, give you some advice. I printed out because this one was so weird, I printed out the schematic and I printed it out on 2 pages, and I went through and I marked all of the capacitors that aren't, because they're not marked with the value. And the same with the resistors. I put the values on them and the values of the capacitors. Now, obviously, I didn't do the tuning condenser because it's a tuning condenser. It's not a discrete device under the chassis. But I did all the capacitors and resistors that matter. So now, while I'm changing capacitors, I'm like, well, what is this capacitor here doing, or what is this capacitor doing, or what is this resistor doing? I can find it on a schematic and immediately have the value and not have to come down here and try to decipher it and jump up back there. The other reason I did it is because there's so many duplicates. You got C4 here, you got C4 in other places. They were just duplicated everywhere. And so to avoid that, I went ahead and marked them on there to make it easier so I don't have to keep referring to the ledger down here. So that's a good tip to do. Now a lot of the newer radios, 40s, 50s, 30s even, late 30s, but more 40s and 50s, they actually put them on the schematic and you don't have to do that so much. And I've never seen one that had duplicates. Like C4 is a .05. There's .05s all over the place. There's C4s all over the schematic. I've never seen that. I've always, every schematic after this and even some before this, each capacitor had its own number. Even if it had the same value, it was a different number. And so down here, you could count the capacitors and know how many are in the set. On this, you can't. You can count these that don't tell you nothing. They don't even tell you that there's 3 of these, 2 of these, 1 of those, which a lot of schematics do. This one just tells you the values, and there could be multiples. Actually turned out, so far I found 17 capacitors. And not counting the electrolytics, they're showing 17 capacitors, but they're showing Mylar capacitors, which I didn't count because we don't replace them. They don't need to be replaced. And so since there's Mylar capacitors, like this one here, domino capacitors, some people call them, you take them out, then you've got duplicates of the others, right? Because you still got 17. So it's just convenient to do this. Print it out on 2 papers, and it's easier to read, assuming you got a good original. So I did that. So anyway, now I'm going to start putting these capacitors in. I segregated my capacitors by value, so I know right away what I need. And I'm going to start to do an example with this braided one. There's another one that's got a braid that goes to ground, and that is hard to turn it that far. That's the other thing I do. It's a .05. That's the other thing I do is when I put capacitors in, I try to put the values facing out. So if anyone else comes along, has to work on the radio, they can see them. This was done in a factory, and they just didn't take, the person doing the assembly just didn't take the care to actually look at that and make sure that the number could be viewed from the bottom of the chassis. Okay, I've got a cord that'll probably be going in the way of the camera every once in a while, and I apologize if the camera moves. But I use this desoldering iron, very good desoldering iron, a Henko FR301, to desolder because it does a really nice job, rather than just trying to use wick, or some people just cut the leads and J hook them together. I'd rather not do that. I'd rather just solder them in. And sometimes, again, you have to. So what I do is just suck the solder out. I wait for my gun to get warm. It was shut off. Getting there though. Give it a second to warm up. It also helps to put a little bit of solder, put a little bit of solder on the tip, and it'll melt it faster. This one's just being stubborn. Blade, there it goes. Okay, they wrapped that one all the way around a couple of times, and it's a braid, so it's not going to come loose. And I don't want to heat that wafer too much. So we got the worst of it. Let's see if we can untwist it. Nope. See if we can untwist that off there. I may not have no choice but to cut this one out because it's a big old blade. That's just so weird. I've never seen anyone do that in a radio. Let's cut them out. Cut that one out anyway. Maybe we can get some of that out of there. I don't know. I don't like big globs of solder, and I don't like big things sticking in there that can cause problems. And cut it off a little shorter. I'm just going to do that. I'm not going to worry about it because it's just not worth the time. All right. and that goes right to ground, to that ground strap. So again, I'm just going to cut that because there's no sense unsoldering all of those grounds just to get this capacitor out. Hard to get in there. Okay. So you see the ground side was on the chassis. And there's that braid. You see how big that is? Look how much solder that holds. That thing, I think that would be noisy as anything with that big old antenna on it. And just to give you an idea, this is a .05. So if we go to the scale here, meter, okay, it's on a nanofarad scale over there. So that's thousandths of a microfarad. And we go on there, it's 0.075 microfarads. 0.075, so, or 75 nanofarads. It's supposed to be 50 nanofarads. So it's 50% over its value. It's supposed to be 0.05, it's 0.075. So that's how bad that is. Now, the max that it would allow at 0.05 would be 0.06, 0.05 or 0.07. So it's bad. Actually, yeah, 10% would be 0.005 would be 10%. So 0.06 is what the max it should be. Okay, so we're going to put in a new one. And that's a 0.05. One of these guys here. Of course, now, you know, they don't make 0.05s anymore. This is a 0.047. And you see it's right on the money, 0.047. So it's supposed to be a 0.05. We're 0.47. We're in tolerance. And as it gets older, it's going to go up. So instead of going up away from 0.5, it's going to actually get better and better as time goes on. And I know which side is ground. It's that one. So that's going to have the longest lead. And the shortest lead is going to be soldered here. But we need to make sure we got enough to wrap around there. I'm going to wrap it around right on there and connect it to the ground. So I'm going to cut this right here and solder it on there. It's a little tricky getting in here because there's so much stuff on that. And I would love to get it wrapped around that band, but that ain't going to happen. That band's got too many things on it. So what I'm going to do, come up around behind that piece of, yeah, right there, behind the piece of shielding that was on the one we took off. Get a hold of that. Let's try to get a little more. Yeah. Hard to get a hold of, and I apologize again for my hands. I know they're always in the way of the camera. Okay. I'll fold that right over in front of them. I can solder that really well, and that's plenty to hook on there, so I'll just leave it right there and put a drop of flux on there, which will help that solder spread. Put a little solder on my gun. And this gun will, you got to have a gun when you're working on these radios because you need the high wattage. They put so many things to chassis ground, you'll never melt it with a pencil soldering iron, so invest in a gun. I'll make sure everything's good. We're good to go there. Bring it over here. And we'll wrap it around that terminal because there's no way, again, to get in there with all that. Ouch. All that braid in there. They just gobbed it up with with that blade. I don't know why they did that. I don't know why they made capacitors that way. I guess they were thinking it would be noise reduction, but it's not noise reduction if it's not a center lead with a blade. It's just a blade. Yeah. Drop on there. Okay. The other thing I do, and you probably should do, is keep plastic, keep it from evaporating. Keep some alcohol in a jar with a brush and clean up your connections. I know they don't always do that. I clean up a lot of the old ones too as I go. But clean them up. Make sure there's a good connection first off, and it makes nice work. You don't have to worry about getting alcohol on any of these contacts or wires because they're gonna it just evaporates away. Alright, so that's one, and you get the idea. I'm not going to film doing all of them. I just wanted to do one so you can see what I do and how I do them, and you see that I use the shortest possible length that I can use. If you've got a little piece of lead left over, just click it out. I'm going to continue, and when I get up here, I'll show you what I'm doing up there when I get to it, the high end. Up in this corner up here, I'm going to fix all this. While I get the motor out, it's easier to get to it. So we'll deal with that, and I'll show you when I get to there. So anyway, I'll be back. All right. I replaced this big old capacitor. I cleared that hole out pretty well. I put it up here. Instead of going over to this junction of all this junk, I just put it on where the ground goes here. I'm going to reroute that, clean it up. But in the process, I found some other interesting things. The this resistor here leaves a lot to be desired. It was stuck on that first spade there of the first that strip. And so was this resistor, and so was these two wires. They were stuck through the hole in the bottom end of it down there, and they have no solder on them. They weren't even soldered. They weren't wrapped around. They weren't soldered. They were barely just making contact. So I don't know what in the world that effect had, but they all need to be spliced in there, and this needs to be cleaned up somehow. So that's what I'm working on now. And I'm moving that big 2 over there. That cleared that all out. This red wire goes with these that are not connected, and so that's why I was cleaning that all out. So we'll see what I decide to do there, but that affects all of this stuff. By the way, I was impressed. This resistor, the first section here, is still good. So that's great. We'll make this look a lot better when we clean that up because we can keep using it, or at least up to here. So these and this, apparently this clip here broke off from up there, from that section there. But when I tested that section from here to here with my ohm meter, it was good too. And it's too bad they broke that off. But you see it's getting a lot clearer, a lot more room. But they were so congested that they didn't even know that these two wires weren't soldered. They were just stuck through that hole over there instead of soldered together. So I don't know how I'm going to clean that up, but I'm going to clean it up somehow. I could reroute them, put another strip on the back here, and run these over here so that they're not all just right there. I do have, no, that's a capacity can. I don't have nothing here. So yeah, I could put another strip here and that would be fine because there's no IF here at all. And that would break up this congestion. I can just run a wire from there to here, leave this resistor there. If it tests good, I need to test it. If not, put a new one, but leave it there. And just run a wire over to here and then reroute these over to the new place instead of where they are. And the red wire, I can just connect it there, and that would be fine. Yeah, or I could put another one in here, but I'd rather not have more congestion here. I don't know. I'll figure something out, but I wanted you to see how so congested that even wires weren't soldered. Not a good thing. All right, I got the power resistors in, and they're 11K at 10 watts, which is much more than it needs to be, but 11K is exactly right. What they had was these two 25K in series, which should be 12.5K. That would be all right, but it's measuring 7.5K, and so that's bad. And of course, that one's open or off. It's a little confusing as to how the wires go, but that's because of the size of the resistors. I couldn't really go too close because I'd have to extend the leads on them, and I didn't want to do that since they're power resistors. So what I did is where this one connected, which would normally go to the next lug on the main power line that's no longer good, I came out to this one. So that continues zigzagging this way or angling this way and then across, which this one would be the furthest one here. Back there. Well, actually, there was one missing, but it would be in there. So rather than them being in a nice straight line, they go in a straight line and then they come up and then they go over, double back. But that's not bad. Now, I see I got a gray wire I got to attach here. I haven't got it on there yet. But the way they went was like that. And what I've got now is these two go together and then it kind of like comes at an angle and then comes back. So it's like a J instead of a straight line. But that don't really matter. That's not that confusing. This resistor here, which was this blue one, was doubled back and making the whole thing cockeyed and stick into this terminal here, which is this point here. So rather than do that, I just ran another wire. I ran it there, and there's already a wire going there from the capacitor. I didn't need to have the resistor going there too. So I just ran a wire back from the resistor back to the same point. So it's connected there too. So the next thing I got to do is figure out where this wire goes, which I disconnected somewhere in the process, and put it back on. I think it actually just broke off is what happened while I was moving all that around. It was a conglomerated mess, as you can see. And so this went up there, and that went all the way into there, and it was hidden behind a whole bunch of other stuff. And so it's much cleaner now, and now it's easier to get to these three that I'm going to need to change and, to finish the recap job. So that's going to be much nicer, and it's going to clear out this area. I got these separated from the lugs so that they're sitting out in space here. This wire, I can push it up in through there. So it'll stay up in there. I'll just either wire tie it or route it in there so it stays away from those power transistors. Can't do it with one hand. But I'll get it to stay up in there. And these are this one I'm going to reroute too around the back and come over. And when I take these off, I'm going to redo this because it goes to the same mess. And I want to clean all that up on that first connector back there. This one here. It's got solder all the way down to, geez, down to there. It's just like a big old bunch of twisted up wires and things they cut out and put in. So we're going to clean that up when we change those final caps there. I'm not too concerned with trying to change those caps yet, but I'm going to go ahead and do that and reattach this. What I started to say is I left these out floating because these are power resistors and I want them to have air cool all the way around them, so that there won't be no wires up near them and they'll be air cooled. If I tightened them tight to the strip, they would be congesting a lot of heat because there's two of them. And so this way they'll stay cool and keep the radio cool. Not only that, I didn't want them to under either one of the tubes, under that tube or this tube, where they're radiating heat up. I wanted them in between. Since we've taken that capacitor out of socket, they're far enough away they're not going to heat it anyway, but even if they did, it's not going to be the end of the world. So, you know, they might heat it a little bit, but they're not going to heat it enough to do any damage. They're far away. You can't really tell from that angle, but... So, I'm going to go ahead and change these, connect this wire, and then change these three, clean that up, and then we'll be ready to do a test. We'll be done with that part. Now, some of these resistors are out of tolerance, so I'll go through before I'm done and clean them up. I went ahead and just clipped this old power cord. I'm going to put a new power cord on there, obviously, and, you know, fix that. One of the wires for the motor, I got to put the motor back in, so I couldn't put nothing in this area. That's where the motor goes. So put it back in and then run the wires down to that before we can power it up again. And there's these two wires here, that one and this one, connect to the motor core, and then the coil connects to this one and the power down here. So that's where I'm at. I just wanted to give an update and show you how much cleaner it's looking. And you can see the box has plenty of room now to get in there, since we got rid of all those gigantic capacitors and rerouted some of the lines, so it's not so much of a spaghetti fest. And still got more to do, but it's looking a lot better. So anyway, thanks for watching. There we go. And the magic eye's working. I don't know if you can see that. Oh, hold on, let me shut this other light off. I watched the magic eye. It's a ring eye. It's awesome. As I get close to the station, look at it fill in. And as I pass it, probably looks pretty consistent in there, but it's a big difference here. Well, you can see it though. That's my local station. Now, I haven't done an IF tune yet. I just recapped it and added the two tubes that were bad, changed a few resistors. I still got a cap here I got to change. Drawing a little bit of power, but doing all right. It's hard to tune without that fan belt. We got to fix that. And I can spin it and get it over there to the other end. That's how that would work. The motor would just spin this to get it to the other end. Doesn't like to spin that way though. Okay, so we got no reception other than the local channel here in town, but like I said, I haven't done an IF tune on it yet or anything. Some motorboard in there.
Then tomorrow, sunshine, northwest breeze, low 60s, mid-40s Friday night. Halloween, sunshine, highs, low 60s. In the GNN Weather Center. Hi, it's Joel Williams from the morning show on My Country 99.
It's a lot of power. And even without all these shields on, not getting no feedback. Of course, it doesn't have the reception yet either. So there you have it. I'm gonna go ahead and continue working on it, but not bad for a new first run. This tube here, the printing on the glass was not very clear. Actually, you can't read it at all. It's gone. So I put a label on it just so we would know. I would know what it is while I'm working on it, but I'll just leave that there. Maybe tape it on with some Scotch tape, because if you write on the glass, it's just going to come off. That might last a little longer. And like I said, I got all the shields to go on yet. There's 4 shields here. So 1, 2, 3, 4. Looks like those are the 4 that'll get them. This one doesn't get a shield. This one does, as you can see at the base there. 1, 2, 3, and 4 would be this one here. And that's what I have, 4 shields. So I think they're all there. And this just doesn't get much interference here. So, making progress. And I just wanted to show what was going on with it. Yeah, that tube don't sit very well, does it? We'll have to fix that. Maybe get a clean socket out there. It goes in. And one back there too. I need to clean these sockets. You know, I haven't cleaned the top yet or anything. I've just been working on getting it working. There was this capacitor going to ground on the, well, the schematic. It looks like it's supposed to be this one here, because this is the ground line coming up here. And so I think it's this one, the C17. It calls for a 0.002 microfarad. And this is a 0.005, so, and it's not a Zenith. So it might be that the guy who put it in just didn't have a Zenith and didn't have the right one. Inco. Anyway, I'm going to make sure that that one goes there and put that one in. Then I've got to change this one. There's still that mystery capacitor that was in there too that also is not a Zenith, that I can't find anywhere on the schematic. So what I'm going to do is count all the ones that, well, you know, there's duplicates, right? We've been down that road before. So I got to count all the capacitors on the schematic and see if they go in there. The one they had here, this one, they have it connected to the one side of the heater element. Have it connected to this side of the heater element to ground, so it's across this. And that just didn't seem right to me to be this one, but it possibly is. This is not ground, and this is not ground. So I don't understand why they had it here, but they may have just put it in the wrong place. But I'm going to go by the schematic, more so than by, what changes were made. There were so many changes made in this radio. It's been a very difficult one to deal with. So anyway, I'm going to go ahead and switch this one out. And there were a couple of resistors that are out of specs, which I'll probably go ahead and switch them out too. Just to make and check the voltages. I do have the voltages here, so I'll go through and check these voltages here and make sure that we're all right. They measured the consumption is 75 watts. We're within that range, so that's not bad. Again, remember, we don't have the right transformer, so that's going to affect it. But all voltages are measured from point indicated to ground using a 1,000 ohm per volt meter. Well, We got like an 11 megohm digital meter we'll be using. Antenna and ground disconnected. So we disconnect the antenna, 117 volts, and it should be at 75 watts. So if I bring this up and leave it on and bring it up to 117 volts, let's see what kind of consumption we're getting currently. Okay, so I'm bringing the voltage up. It's going to take a while for the tubes to heat up, just so I don't get copyright issues. I'm going to turn the volume all the way up. Okay, we're at 110 volts. So we'll bring it up to 117. Right there. Oh, too high. Back it down a little. Okay, that's about 117. And we're drawing 64 watts. So we're doing really well because it's rated at 75. And what a sound. It's got an incredibly good sound. That's with the speaker in a box.